Hi, Daniel or Dan. So actually, on your Dan North website, there's Daniels, and usually you are Dan. So are you Daniel or Dan or both?
So I spent an awful lot of time being Dan North. We have two wonderful adopted boys. We adopted them 5 years apart. And when we adopted our first, we decided that we were going to align our surnames. So I've been Dan North my whole life. My wife's surname is Terhorst, father's Dutch. So we both became Terhorst North with a hyphen, and Dan Terhorst North just sounds odd. So I went with Daniel. So there you go.
For me, it doesn't sound strange. So Dan Terhorst would, I mean, for me sounds whether Daniel or Dan, same. But you prefer Daniel these days, right?
I prefer Daniel these days. To be fair, I'm like 50-something years into being called Dan, so I get it wrong.
Okay, so maybe I will mix up today with Daniel and Dan.
Fantastic.
But cliffhanger last time, you said J2E is terrible and Java is weird. And I said, this is not my opinion. So we have to discuss that just because. And I also thought about, what was it? Kaikaku, I think, right? Kaizen and Kaikaku. And this was also a good one. And what I think what happens is the Kaizen and Kaikaku. So first Kaikaku, like big shift happens, and then we have incremental improvements. But in software, I think through the incremental improvements, we are going to exaggerate, and then another Kaikaku leads to almost the same results as the first one. So there's like a circle, like, microservices and monolith, for instance, right? So there was a monolith. They say, no, it doesn't work. And it didn't work because people exaggerated. We had millions of dependency and no one knew what's going on. And they said, okay, now the remedy is to have microservices. And even Netflix and Uber, they exaggerated. They had millions of microservices and didn't know what's inside. And then even they reduce it to a I would say reasonable amount of services, and now we have like a monolith which is well organized. But I think having something organized is just a good idea, right? So we don't have to wait 20 years to find out that if we build big software, it has to be structured. So this was what I thought about the entire time, actually.
So yeah, I think what we've got is two separate things that are worth teasing apart. What I think you're describing, I describe as a pendulum.
Okay.
And what happens is someone comes up with a position, it's usually quite extreme, and then we all go chasing after that position, and then we realize that it doesn't work, and then we say, okay, well, what can we do instead? And then we get another extreme. And that comes out of salesmanship, right? This is someone says, microservices will solve all your problems. They tell you, rather than looking at cost benefit, we just look at benefit. Okay, we don't look at, and for me, it's all trade-offs. Okay, so what am I trading off when I take a big lump of code and break it into pieces? I'm gaining, if I break it into the right pieces with the right boundaries and the right size, I'm gaining cohesion. Right? Each of those lumps is more cohesive. Each of those lumps might be, in domain-driven design terms, each of those lumps might be a bounded context. And within that bounded context, all the language is consistent. All the meaning is consistent. I go to the next bounded context, the language is different.
You're familiar, right, with maximal cohesion, minimal coupling?
Well, and this is the thing. So we can talk about maximal and minimal, but even then, there's trade-offs. And so we need to understand what we're trading off. So microservices to monoliths is a great one. Insourcing and outsourcing is another one I see a lot. And that tends to swing, the pendulum swing for that tends to be a new CIO, right? Or a new CTO comes in.
Yeah.
And they say, we're going to outsource everything. We're going to reduce costs by outsourcing everything to near shore or offshore or whatever. And then they outsource everything. And then they discover that when you outsource, you save money and you lose all control over architectural decisions. You lose a lot of quality, not because foreign developers or whatever, offshore developers are less good or less experienced. It's just they're less invested. It's not their stuff. It's stuff they're doing for someone else. If it's your stuff, you're more invested. And so So, well, hang on, we're now getting software quality problems, or the change isn't happening fast enough, or whatever it is. We're going to bring it all back in-house. We swing it all back in-house. And this pendulum swings every 3 to 5 years, which is about the tenure of a CIO, right? But there are models for looking at exactly this and then making the right trade-offs. So there's a fantastic model by a guy called Neil Nicolaisen called the purpose alignment model. And it's one of these 2x2 type things, a little quadrant model. And on one axis, you have business criticality, so how critical something is. And on the other axis is differentiating, so how much it differentiates your product in the market. So examples, non-differentiating critical would be things like your payroll, email, right? So no one's going to come and work at Adam Inc. because you've got the best payroll system, right? But they are likely to quit if you don't pay them. So and unless your product is email, like having working email is really important, but you don't care. And so
this is not entirely true, because what I did, I had workshops at the airport in Munich, and until pandemic, then they became online. But and I get so many requests for what was it? They wanted US wanted to pay by a credit card, and it is somehow hard, right? So I just for them I created Meetup and Eventbrite, registrations. And just because of the registrations, I got a lot of attendees from US, India, and Africa, just because of invoicing. Without the invoicing feature, right? So I would have less attendees, actually.
And and this is why the model is so brilliant. It's not necessarily that email is non-differentiating. Is whether it's differentiating for you. And it turns out that when you're doing remote training, and there's only one Adam, so it's not like you're doing generic training. You're not doing Scrum Master or whatever. You're doing Adam Bin's like custom brilliant Java stuff. There's only one of you doing it. So now having Stripe or whatever, having some payment gateway opens a new market to you. It is differentiating. Right?
Exactly.
And so that is something that you then say, do you know what? I need to find a really good version of that. So the Nicolaisen model, the purpose alignment, it says if it's non-differentiating, you don't need to be better than anyone else. You just need parity. Right. It just needs to be as good. Right. Your email needs to be as good, but it doesn't matter. But then if it's your product, like I do training. If my training material, I don't want to outsource that, like building my material, because my class is my product. Right. But I might use a designer to do some of the slideware, right? Because I'm not very good at design, but having good, catchy slides is going to be differentiating. And so what it does, it gives you a model for deciding what you should build in-house, what you should become really good at, what you should try and just outsource and get someone else to do who's really good at it. And then the bottom left corner, which is always the rubbish corner, right? So the bottom left is non-differentiating and non-critical. He says, just try and get rid of it. Like, why are you even doing this? If you can do it in an Excel sheet or a bash script or whatever, just get rid of it.
But what I think, if the non-differentiating is also appealing, magic happens. So if take a look at Apple, right? So I was in an Apple store, I had some issues with my hardware, and I was a bit disappointed about the entire process. I say Apple should handle that better. Not that that they tried, but the process didn't. For instance, I wanted to order something into the store. It was not possible because they say in Germany it's impossible. It's like, how come? I mean, this is so simple. Just do it, right? So why it is not possible? And this was not differentiating. It's not like, you would think first about Apple, but I thought, come on. So what's going on? So I was a bit disappointed because I assumed, because they built great hardware, they will also able, to have more flexible processes. So I think if you whatever is consumer facing and even not differentiating, but is great, it magic happens then. You become a way better than your competition, I think.
Well, and you're absolutely right. And this is the thing, is that it is actually genuinely differentiating. There's some great stats about the fact that people are much more likely to say positive things about a brand than negative. Like, I just had the most amazing customer experience.
Exactly.
Because we're surprised, right?
Yeah,
we shouldn't be surprised, but we are surprised. I went into the the so-and-so store, And this thing, so I just changed my home broadband.
Mhm.
There's a company that's working in London called Community Fibre. I think they're only in London. And I went from paying £50 a month for 150 megabits to £25 a month getting over a gigabit.
Wow.
And it just worked. And you know what? The engineer that came was really polite, did a fantastic job of cabling, like invisible cabling. You couldn't even see it. And cleared up after himself, made sure I was set. And it was just the most brilliant experience. And I have a loyalty link, and I've given it to 3 people so far, and I'm mentioning it on your show.
Yeah.
Do you know what I mean? Now what do I need? I need an engineer. What does he need to do, or he or she need to do? They need to drill a hole in a wall and run some cable through. That's the job.
Yeah.
No. Actually, no. The job is to leave the customer telling people how brilliant the experience was.
Yeah, but in your definition, this would be non-differentiated.
Well, no. This is the point: is that the task itself is neither is or isn't. The differentiation piece comes from your business strategy.
Exactly. Okay.
So if your business strategy, if you say, as Community Fibre, I want to compete with BT or Sky or whoever does fibre in the UK, that sort of very narrow view of your product would mean you're absolutely right, it's non-differentiating. But if you say, no, my product is customer loyalty, anyone can do broadband, right? We're going to be cheap. That's fine. We can compete on price. What we're going to retain people on is they have a brilliant experience with us, and so they've decided that customer experience is part of their product, and therefore anything that's customer facing is differentiating. So they want to own that process. They could outsource it to a bunch of I bet there are white label fiber installing companies. I'm sure that thing exists. Yeah. But they're not going to go to them.
So it means our business strategy has a direct impact on architecture and design.
Yes, and this is the brilliant insight from the Nicolaisen model, is as your business strategy changes, different things either become or stop being differentiating. Right? So true example, this is UPS, the men in brown, right? They were very much the third by a long way courier in the US. You had FedEx and DHL owned the market, and then UPS were these startup. And and they were competing and they were doing okay. And then what they realized is, because they talked to their customers, is people are much less worried about when something's going to arrive when they send it as a parcel. Especially, US land mail takes days, weeks, right? It's a notoriously slow process. They're less worried about when the thing arrives. They want to know where it is. There's like a sense of, obviously they don't have any control over that, but there's a sense of and if I know where it is, I can kind of make plans. And what they did is they took their internal logistics system and they turned it around and put a web page on it. and then you had a customer portal. Which is why all these UPS numbers are these incredibly long numbers, because they're only ever supposed to be used internally, right? But now I can go to the UPS website and I punch in my very long tracking number, and it tells me it's stuck in a bonded warehouse somewhere. I don't know what a bonded warehouse even is, right? But I know where my parcel is, and I know that it's 5 days away or something, right? And because of that decision, they said, right, our product isn't moving stuff around. Our product is letting people know where their thing is. While we're moving it around.
But UPS is more than that. What I remember years ago, I met someone who was a huge UPS fan. And what he knew is all the tracks. I remember they said there are special brands with special doors and whatever. He knew everything about UPS. And I was this is incredible. Why you bother with UPS? But he knew about it. And this changed a little bit. So UPS became more or less generic. You know what I mean? So now it is they don't have, at least in Germany, special trucks. It is, for me, actually, I prefer DHL over UPS because the tracking is better, for instance, than UPS. Yeah, right now. And but they were far more than the competition, I would say, 10 years ago, because of the differentiation. Special trucks, special branding. They had a special appealing, not for me. But there are lots of fanboys who are really, drawn into the entire UPS brand.
Right, and who's a fan of a courier? I mean, you're doing something right if you're a courier and you have
exactly.
fans.
Exactly.
and again, but Adam, this is exactly the point. So, UPS realized that knowing where stuff was the product, and so they made that available. And then DHL and FedEx then became fast followers and did the same thing. And so now this thing that was differentiating now just becomes parity. Right? You wouldn't use a courier now that couldn't tell you where your stuff is. Yeah. And this is what happens is that there'll be a leader, then there'll be fast followers for some new thing. Every single smartphone in the world looks like an iPhone.
Yeah.
Right. And has done since 2007.
Yeah.
Yeah. And when that first came out, the idea of a full touchscreen, without buttons was completely unheard of.
Yeah.
And it was differentiating for some time. BlackBerry desperately tried to keep people on buttons on keyboard.
Yeah.
But eventually they lost. And now every single phone looks the same. And so now we associate smartphone equals rectangular slab, right?
Yes. Yeah.
I suspect there'll be a new thing soon. I know Apple's got a folding phone coming out. I know Samsung tried a folding phone and now I think they're ditching it. So I don't know what's going on there. But there will be the next format, and as soon as the next format happens, people will look at the slab phone and go, "Wow, I can't believe we suffered that for 20 years."
Yeah, exactly.
And this is the thing. So the next thing comes out, it's differentiating. You get fast followers, it becomes parity. And while we're during those cycles, that's when you decide we're either going to build this thing in-house because it's our differentiator, or we're going to now pass it out to a commodity partner who just does that. Apple famously gets all their screens from Samsung.
But maybe not pass to commodity partner, rather than, if possible, do something as a service.
Just right, and this is the thing.
Not build it, just use it.
Yeah, if you're going to outsource it to someone for which that is their differentiator.
Exactly. Yeah, exactly.
So, Apple gets all their OLED screens from Samsung because it turns out it's much cheaper to pay Samsung in bulk for screens than it is to set up your own screen fab plant.
Yeah, exactly.
But and here's another fun twist. For decades, Apple computers ran Intel chips. Right, and then Apple a few years ago famously decided they want to go back to the RISC kind of system on a chip type architecture, completely in secret. Launched Apple Silicon, the M1s, and I'm speaking to you now on my M1 Max that I bought in 2021. It is still running like a boss. It's a 5-year-old computer. And I have no plans to upgrade it anytime soon. And I can't remember the last time I held onto an Intel machine for more than a couple of years.
Same here.
It's so far ahead of the game.
Yeah. Yeah.
So but back to the original plot, the Kaikaku and the Kaizen is... So we have these two things going on. One is the pendulum swing, where someone says, let's do X because X is great. Rather than saying, let's do X. X has all of these great aspects and you're trading off Y. And now we can make an educated assessment of that. We just go chasing after the X and we don't notice the Y, right? And then the next person comes in and says, microservices are incredibly complicated to observability, to monitor at scale, to manage. Let's go back to structured monoliths. And all the monolith people go, ha, 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 ha. Mainframes are incredibly expensive. Let's not have mainframes and terminals. Let's have lots of PCs on everyone's desks. And then now we go to cloud, which is basically mainframes. And, you're using AWS, you're using GCP, and you're using this super powered laptop on your desk as basically a dumb terminal. But
even
in code or whatever.
In the mainframe era, it was the same. So I still know some developers, mainframe developers. They do PL1 and RPG.
I've written PL1.
S400. I know the largest installation of S400, and they are extremely happy because it's maintainable. So I was curious why, and the main feature of that is, is that the transaction system and the database were in the same memory. So actually, if you try to implement the same with J2E, let's say in my world, or Quarkus or whatever, it would be really hard to do that. And they can handle almost half of the world on one machine, which is incredible. And I look at that and they ask me, could we migrate it away? And I say, but why? If it works and everyone is happy with it. And we talk about patterns, before image, after image, what I remember, group sorting, like something. So I learned a lot for NoSQL even, from what they did is actually I could apply some of their patterns to DynamoDB. And they would actually, I'm surprised that, I'm surprised that there's not more happens on mainframe, because some architectures could be the right fit. Back to mainframe, everything on memory. So this would be actually the exact opposite of microservices.
So yes, and I feel that you're conflating two things. You're conflating the OS 400 model with mainframes. You could take the OS 400 architecture of integrating, the brilliant thing it does, one of the brilliant things it does is you don't, as you say, you don't have the distinction between memory and drive, memory and disk.
Yeah.
You have storage, and the OS figures out which of that storage should be durable.
Yeah.
So you put stuff into the store, and the store is durable, right? And the way you scale that is have more OS 400, AS400 machines, mini computers.
Yeah.
Now that system architecture was directly in conflict with the von Neumann model, where you have memory, store, and CPU. Now, what we're seeing is, and I think it's brilliant actually, is we're seeing more alternatives to that. So the whole SoC model, system on a chip model, where you have memory, compute and store on the same silicon. Yeah.
M1.
In one, and you have lots and lots and lots of those, and that's how the Apple Silicon model works. That's how RISC used to work. But now, if you look at, say, AWS, an awful lot of AWS compute happens on SoC nodes, and that's becoming a much more prevalent model. And again, I don't know what the next generation is. I don't know if it's much more of that, or if that's a stepping stone on the way to something. But I feel like I'm going to massively agree with your PL1 buddies. I think having to not consider whether data, the durability of data, right? Having that not to be a concern when I'm solving computing problems is brilliant, right? And we have to decide what's in, and of course then what happens with distributed computing, which is the Java's kind of, I guess, happy place. That's where it's best known. Is you are then made responsible for more of those layers of indirection. So you've got memory, you've got hard drive, you've got the network, someone else's memory, someone else's hard drive, and then you've got the coordination between those. And I love Martin Thompson. I was quoting him recently. He came up with the term mechanical sympathy. He built the LMAX trading exchange. He and Dave Farley and their team in Java. They were running on a single core. They had an overhead of something like 300,000 trades per second. Right, so a trade is actually a match of some quite complicated algorithm stuff.
This was the ring buffer, right? The
disruptor, and it was just. How do you get 300,000 matches per second on a core? And he does this. He does a whole series of brilliant talks. He basically says a 3 gigahertz chip, right? 3 gigahertz means 3 billion goes a second.
Yeah,
you've got to be really, really not paying attention to not be able to do stuff with 3 billion goes. But it turns out that we're not paying attention. Going to the cache, going to L1 cache is like 3 goes. Yeah, going to memory is 30 goes. And he talks about goes instead of nanoseconds, and then suddenly it all makes sense. Going to the network is a several million goes, right?
Yeah.
and you're like, oh wow, it's really easy to completely waste away all my goes, and the whole point of mechanical sympathy is it's just good, clean architecture, really simple data structures, things that pack well into arrays. Understanding how your L1, L2 cache works, understanding the cost of a cache miss, really simple, understanding your computer architecture all the way down, right? And understanding your network architecture. And once that's in your head as a developer, and again, Java does this brilliantly, And the JVM does this brilliantly if you lean on it as an architecture. I mentioned this to you before, back in the 2010s, I was writing high-frequency trading systems. And in Java, and they were like, the C++ folks are going, oh, you'll never make it perform in Java. And we're like, have you seen the JVM? And we had Java-based trading systems that were outperforming custom C++ trading systems, or certainly on a par. They were very, very similar. Because we could do things like pinning the fast algorithm loop to a single core. So we had control of the CPU all the way down. We were writing bytes directly onto the network card memory because we could, right? Because Java has the APIs for mmap for various unsafe functions, and so we were doing like zero copy trade writing effectively onto the network. And stuff that would have been thought impossible in a VM language that's garbage collected, that's all of those reasons that people used to kick the Java puppy. And it turns out you can get mind-boggling performance just by understanding how your system architecture works, how your programming language works, how the VM works, and the fact that it is a spectacular piece of software engineering.
This is the problem why I still do Java, because the hope was, I remember, as Scala were around, I say, okay, maybe there will be a project where Java is just not scalable enough or whatever, and I will have to do reactive programming or Scala or whatever. And never happened, actually. Even the biggest project, just JVM and even simple code was enough. This was the stunning part. So we just wrote simple business code, and it was fast enough. This is the amazing part of Java. And then I started, to build a simpler and simpler and simpler code, almost trivial code, and it was still fast enough. And fast enough is the point. We could, of course, optimize, but the question is why, right? So if it's fast enough and understandable, maybe the understandability or maintainability is better than 5% better performance. And in my consulting gigs, if it stopped working, was often because of optimization, wrong optimization. Caching, pooling was a big one. I remember countless projects where we removed caching and it worked better than without, right? So than with caching, for instance, and or object pooling, which destroyed the garbage collection. So,
so Adam, I have to share a very short story with you.
Yeah,
I was on a Java gig in a UK bank in the mid 2000s, and we picked up some legacy Java code and we were trying to clean it up, and it had been written by an army of contractors that had swarmed in and then disappeared.
Yeah, sure.
And it was a service tier across 3 kind of legacy stovepipe systems. And the idea was you had a single API over everything, and it would figure out where the messages went. And we were trying to simplify this because it was really clunky. And we had in this one code base, we found 6 different implementations of caching, of database caching, right?
Very popular.
It gets better. So, and I was working with a guy, I'm going to name check him because he's lovely. Alex Harrin, his name is. And he became known as Alex the Deleter. Alex the Deleter.
I already like him.
Cache to cache to cache, deleting the cache and replacing it with like 2 lines of EH cache hibernate configuration.
Yeah.
And then the pinnacle of this was about 6,000 lines of code, of one cache, was 6,000 lines of code. And we were able to prove that it had never run. Because it couldn't. It would fail as soon as you ran it. And so we deleted this 6,000 line, we called it the crap cache. Of all the caches, this was the crap cache. We removed the crap cache and again replaced it with like 2 lines of EH cache configuration.
Maybe this was my project, because in one they had never cached it because the key was wrong.
Yeah.
And for instance, so this was actually, it was worse with caching because we consume memory and we never had
the head of the cache management and none of the actual caching.
Yeah. So it was maybe more like, history cache. So whatever happened in the project was in the cache, but we never were able to read from the cache. So this was actually, Yeah, we are in the same project, I see already. So this one, 6, maybe not, but 2 caches or logging. I was in project with multiple logging frameworks because this was
you can't have too much logging.
Logging, configuration, and caching. Because if you hired consultants and not all consultants were interested in the business logic, so every project, they started with configuration, caching, and logging. This was the simplest possible thing to do in Java.
Yeah.
But maybe I don't think we can cover BDD, but we can cover, your J2E, J2E criticism, and you like Java, so there will be no discussion. But J2E. So just briefly, because I started with Java before J2E, and the problem I had back then is there were so many competing implementations and servers, so I couldn't understand the world. So there were like 15 to 20 different application servers back then. Persistence, Power Tier, Tidestone, Gemstone, lots of stones, interesting thing back then.
Object Store.
And Echelon was, I think.
Yeah, stones were common, weren't they? Now you mention
stones
it.
Were very common. Then the Tenga, which became WebLogic, and there was this from eBay, the application server. And for me, I say this is impossible for me to be consultant because they are so different. I cannot just learn 20 products. And then J2E came out, and I say that's actually cool. Because I learned it once, and then I know it, and this is what happened. And the first I ignored EJBs at the beginning because we had servlets and Java Bean solutions. So there in lots of projects, so there was pointless in migrating to EJBs. But I played with it, I had to play with it because I delivered some courses for Sun Microsystems about EJBs, which is a funny story because my name is Adam Bean, and they couldn't believe that I teach Java Bean and Enterprise Java Bean courses. So there's no way your name is Bean. It's like, yeah, it is, but this is spelled differently. But this is...
You said, not only is that, my middle name is Enterprise.
Yeah, exactly. So I should rename myself. But lots of fun back then. And the first EJB specification was the configuration was like DSL with Java, and it was serialized. And then in year 2000, there was an evil book from O'Reilly, Java and XML. And this book changed everything because I remember 2 months after release of the book, in some of my projects, they try already to store XML in the relational databases, which led to explosion of storage. And then Sun, all the deployment descriptors happened, which I hated with the EJB jar XML and web XML and J2 XML. And I always tried to generate them with Xdoclet, which worked somehow. It was slow, but it worked. And then the Xdoclets, Java doclets, were more or less one-to-one translated to annotations with Java 5. And beginning with Java 5, it was 2005. For me, it was perfect because the code we wrote back then was a little. So in order to have, let's say, and this is 2005, this is 21 years. For 20 years, it is lean. Before 2005, it was problematic with the XML. I really hated. And this is why I never got the Spring thing before 2005, the Spring framework, because I briefly look at a Spring framework back then, and it was very usual to have a Spring applications with more XML than Java. So the XML configuration was longer than Java, and I say, you are all crazy. So I don't. And what I never got is why they name interface and impl. You had like order impl. Customer service impl. So the naming, what do you do if you go to second implementation? You will call it impl 2 or impl 3 or what's the idea, right? And so I ignored Spring and stick with Java EE. And to this day, actually, this was the best decision ever for me, at least, because all my projects look like this. And if you have, let's say, a JAX-RS endpoint, JAX-RS, what you have a class with path. Let's say we had UPS, so let's say orders, and the orders one method with get, and you see your orders or tracking, or your parcels, maybe not orders, parcels, parcels results with path parcels get to one class, one method. You are done, and then you just say add inject another class and you have 2 classes, and you are done. This is basic J2E project right now, and this is stable for 20 years. So I did some fun talks, even I think at JFocus. By the way, I saw you briefly at JFocus, but because of agenda changes, because the Victor had to talk before me or whatever, I had no time to say hello to you. So there was some, some agenda changes which affect me. So I saw you briefly, but I had no time to say hello, and I only saw that your talk is very popular. And with that, so what I did at JFocus, I think I also mentioned a 2014 Java user group meeting where I pulled some code and showed how easy it would be to migrate. So the point is, it never changed. And now it comes the cool story ever, the coolest story. What I do right now is, because the thing didn't change for 20 years, and there are so many blogs, resources, and books, LLMs know it really well. So what I can do right now in my projects with 3 words, prompt of 3 words, I can generate almost perfect applications, which are very token efficient. Inference is cheap. So I would say it is a huge success, actually. The problem back then was, what you said is, too many consultants who got into J2E, they really love it, and they used countless patterns and introduced bloat without a reason. This was a different problem. And another problem was one application server was the WebSphere Classic, which booted for hours. This is what I didn't understand. What they do, maybe they had already an early Bitcoin mining in place or whatever happened during the boot. But it was way too slow. And I remember in one project, we had just to update, the EJB container with WebSphere. And this was like 1 gig. They said launch is not enough. I couldn't even understand 1 gig of bytecode. Imagine, this is incredible. I know Glassfish was 60 kilobyte, the entire EJB container. So for me, J2E, great success. And I do J2E more or less right now. And we save money with it because Quarkus is the fastest, and we use Quarkus serverless with J2E API. And because it is so well known to LLMs, we have a minimal skill. We can, it is maintainable. It is well documented. It runs great. So this is why I wanted, this was the cliffhanger from last time. And for me, the J2E is like Linux. It is boring. It is solved. So the dependency injection is solved. If I need persistent, it's solved. If I need JAX-RS endpoint, is solved. I pick a runtime, Micronaut or Quarkus, because they are the fastest. And we can focus on the differentiating bits, like, what my clients would like to have. And we forget about the infrastructure. There's no discussion. We just pick whatever is well documented, is solve problem. And we are multi-vendor. So this is my take on it.
Mm-hmm.
Yeah.
So, clearly we're talking about 2 different periods of time here. So my beef with J2E is the roughly decade, probably less than that, 7-8 years, that I was a J2E 1 person. I was using Java since late 90s, and I think, okay. So the bottom line, if you like, just the what's it, the tweetable bit, or no, we're not on Twitter anymore. The tweetable
Blue Skyable.
Yeah, exactly. Well, I'm on the Mastodons these days. It was, and and even the folks involved in it will acknowledge it was vastly over-engineered.
Mm-hmm.
So a bunch of the assumptions in it were that different people, different roles would do different things.
Okay.
Yeah. So you had half a dozen of these, not just that they were XML files.
Yeah.
Half a dozen XML files to do one thing.
Yeah, agreed. Mm-hmm.
We then had Sun, made a.
There was this deployer, assembler, component developer.
Oh my goodness, all of it. Yeah. And if you were doing all those jobs, you basically just had a ton of admin.
Yeah.
And there wasn't the tooling support. Yes.
I became
many
almost
years later,
schizophrenic, with that.
Yeah. So exactly. So many years later, the tooling has matured now. At the point where it is now effectively a legacy. There are some people writing J2EE code, but there are many more people not writing J2EE code.
I think we are writing J2E code without noticing, Because if you take a look at Quarkus, the entire thing is J2E, but no one talks about it as J2E, you know.
Well, except that it's not. J2E is the standards, right? Yeah. The fact that I'm talking about J2E was at the point where you would build your own car, right? The fact that we now have automated car assemblies doesn't make the car any less complicated. It means you don't have to worry about it anymore. Mm-hmm. I was using J2E. You and I were using J2E at the point where you had to worry about every element of that car.
Okay.
And the massive mistake that Sun made, and they made some mistakes. I'm a huge career Sun fanboy. My first proper Unix machine out of university was a Sun 4, one of these little boxes like this, mm-hmm. with a vast monitor on top of it. Mm-hmm. And I couldn't believe that this little box was the server because mm-hmm. it was just so powerful, right? And then they did the pizza boxes, mm-hmm. and then they did Solaris and all of that. One of the few qualifications I have is I'm a Solaris 2.2 sysadmin.
Oh, I'm not that. So a little bit sad. But I was also a huge Solaris and Sun fan. Uh-huh.
But what they did when they published J2EE, which was a collaboration between Sun, Oracle, IBM, some other folks, but primarily those three.
Novell. Yeah,
Novell. Mm-hmm. Was they laid out what they call blueprints. Mm-hmm. And the blueprints kind of were like a market stall of all the things you could do in J2EE. And you had your remoting and your JNI and you had your EJBs and your session beans and entity beans and blah. And rather than saying, here are some popular patterns, use cases, they said, here is the market stall, right? The blueprints. And then exactly what you just described. A bunch of folks, well-meaning folks, believed that the way you were to build 3-tier software was to have every single one of these things.
Exactly.
Isn't it? Right?
Exactly.
And I spent years of my life writing get set, mappers, DTOs, database calls. Yeah. Oh, coming back, get into the script.
Until Dozer, Dozer? Remember Dozer? Yeah. Mm-hmm.
Well, so I when Java 1.3 came out, which had
dynamic proxy,
two things happened. One is Orion Application Server happened, which was the first application server that said we don't need to do code gen, we don't need to do EJBC. Mm-hmm. And I was on the EFNet Java channel, the IRC channel with the Orion folks.
They were from Sweden, right?
So Magnus and Carl. And they were just lovely, lovely guys. So basically a couple of students built this as a college project.
Yeah.
And the hilarious thing is, so the entire download was 6 megabytes.
Exactly. There was a tiny
6 megabyte download had the full J2EE stack in it.
Yes, with user interface.
with the database, with EJBs, with servlets, with all that 6 megs, and it would start in milliseconds.
Yes.
And I was writing. So my first open source contribution was a thing called XJB, mm-hmm. and XJB was because WebSphere took so long to start, mm-hmm. and because we were trying to do TDD with effectively entity beans. Mm-hmm. What I did was I started with an entity bean, and I tried to compile it and run it, and I got a stack trace, and I basically just started writing code until I no longer had stack traces. And that meant that I could now build, and this thing still exists, XJB. It'll only run against Java, EJB 1.2, I think. So you could write your entity beans, write your descriptors, and then XJB would run it, so you could do TDD on your entity bean. Once you were happy with it working, you could then plug it into WebSphere, and it would probably work.
It's almost like LLMs back then, eval loops. So until it works. It really agentic development, right? Yeah. So 20 years ago.
Yeah, exactly. And this was like, so now I could do TDD, I could do REPL, effectively, development of EJBs. Mm-hmm. And it sped our team up like enormously, and we were able to do stuff. But then I was before I joined ThoughtWorks, this is in the late 90s, I was on a team of contractors. I was a contractor on a team of contractors working for it was a vehicle leasing system. And there were something like 30 engineers on this program. Mm-hmm. And all of us at good contractor rates. All of us could get double time if you came in on a Saturday or Sunday. So what would happen? They'd goof around and then they'd come in on a Saturday or Sunday and go chink, 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 like this. And the whole thing was writing get set, get set, get set. So I sat there one Monday morning. I remember this vividly. And I was like, I bet I could do all of this with I didn't know about Orion then. I said, I bet I could do all of this with dynamic proxies. So I wrote basically a dynamic proxy. I wrote effectively a skeleton of Orion that would take, just the XML that we had, parse it. There was good stuff for parsing XML in Java, pull out what was needed, and do the internal glue. And then it would go straight to the database. Didn't need a DTO. Get the data, position it into the servlet, and then put it on the screen. And I wrote this thing, and it was going to save about 2 days' work per thing.
Yeah,
it would take 2 days' work down to about 20 minutes work.
Yeah,
and I proposed this to the guys running the program. I said, "Look, this will make things so much faster." And they went, "Yeah, we're not going to use it. Right? We're busy buying our houses.
Yeah, exactly.
We're busy coding myself a new minivan," and that they refused to use this much. And this, to me, this is what flipped the bit. It was so much of J2EE, the part of J2EE that I have a beef with. So much of it was admin code. It was pointless, zero added value admin code.
But it was self-made problems, right? It's just like it was what you did. I also did. I never understood the getter setter, and to this day, I still see in code reviews pointless copying, and I say, why you are doing this? Because of decoupling. It's like, look,
it's a best practice because it's decoupled. Because it's
what I never understood is but if you have two classes which are identical in two packages, and they were always identical, there's no decoupling, right? So if you're copying this always, and you always, keep in sync all the getters and setters.
It was more than two.
Yeah.
You had the view bean, you had the entity bean, you had the session bean, you had the DTO, and you had the database schema. You had the query.
Yeah. And I say, if something changes in the database, and all layers are affected, if all layers are affected, the design is wrong. Period. So, but if you change the database, and only one class is affected, this is a good design. So we have decoupling. Super cool. So this is Java open source programming.
And this is my signed copy from one of the authors, Joe Warnes, who's a buddy. And this was the book that introduced Xdoclet, JUnit, WebWork, Hibernate. This was the first time all of these things were kind of brought together.
I also have this book on my shelf.
It's an absolute classic. What year was it? Oh, how about that? One of the authors is Mike Cannon-Brooks. This was before.
But regarding entity beans and EJBs, without dynamic proxy, it would really hard to do something different, because before dynamic proxy, the interfaces and the home and remote and the class, they were implemented that way because of deployment time, code generation happened.
Yes.
With dynamic proxy, we could skip altogether. We could just have a simple interface and have just a proxy pattern, stock gang of 4 proxy pattern, and implement everything in the proxy, like what RME did. So I would say for that, in 1997, the design was not as bad, because it was no other way with stock Java to do something.
Well, I don't know, and this is the thing. I've never gone back and given myself those constraints to see what I would have come up with.
This would be interesting.
Everything about J2EE strikes me as a series of premature levels of indirection, premature seams designed by committee to cover all possible cases, rather than something that you would say, okay, let's take a bunch of use cases, a bunch of genuine use cases, and figure out what the simplest thing would be that would give you exactly what Adam wanted back in the 90s, right? I don't want to have 15 different data stores. Yeah, I get that. So the one part of the whole J2EE world that made sense to me and that still makes sense to me is JDBC. JDBC was brilliant, continues to be brilliant.
It was part of Java, actually.
Well, no, you're right. You're right. It predates J2EE. It was part of Java 2 Server Edition.
No, it's just JDK. I think it was introduced JDK 1.1. Just Java SE. Just Java. Just stock Java.
Yeah, which is J2SE, right? Yeah. So they call it J2SE.
Yeah.
So you're right. JDBC was core Java, which means there is nothing in J2EE that I think was good.
But wait, maybe the definition. What for me J2E means, or J2E, there is no more J2E. So it was renamed to Java-E, now it's Jakarta-E and microprofile and core profile, but I don't care. Let's call it J2E and I mean whatever we associate with it. What for me is, if you go to microprofile.io, there's a core spec. If you click on it, you will find specs like dependency injections called CDI, then JAX-RS, and JPA. So with that, you can build 80% of enterprise software already. JSON Web Token is also there. And so what remains from back then is not the deployment roles. They were killed in 2005. XML was killed in 2005. So there's, I think, even no mention in the specs anymore. Entity beans don't exist anymore. So we have JPA, JAX-RS, CDI, and bin validation and stuff, some supporting utilities, I would say. And now the cool part happened is a few years ago, Python people wanted to run Java in production for reasons. So they have specific reasons, and they asked me what they should do. And I proposed, take a look at Quarkus. And they were confused because if you take a look at Quarkus or Micronaut, they are, if you read the tutorial, they will show you like 20 possibilities. You can be reactive, non-reactive. You can have, the annotated way or builder way or whatever. And they say, look, this is way too complicated. And I say, why? I never read the tutorial. And they ask me what you are reading. And I pointed them to the spec. And the beauty of this spec is there's only one way, and it's actually readable. It is way more because they don't offer all the choices. All the Jakarta, microprofile, whatever we call them, specs, they have written really well. This is boring, but exact, precise. You can read that and you see the path, what to do, and you are done basically. So it will work. So this is the first thing which I really appreciate about Jakarta and microprofile is the quality of the specs. And there is a DIN norm or ISO norm. RFC. And this RFC defines what shall, must, not must, and so forth. What is the meaning of it? And all these specs were written in normative way. And now the cool story is, because they were always opened, all LLMs were trained on the specs. So, and this is what I do is now I'm grounding the LLMs to these specs. So you are only allowed to generate JAX-RS code. And the LLMs generate with a very short prompt, beautiful code, because they were trained on the patterns and so forth. And they don't know, by the way, your time with the deployment roles and XML. This is maybe it disappeared from the internet, God bless. So we have only the newest stuff. And the newest stuff is actually really productive.
I still bear the scars. The trauma hasn't gone.
No, for me as well, because I had to fight. The problem with me, I was always freelancer. And as I had to fight against, huge consulting companies and try to explain that I don't understand why we map everything 20 times and Ruby on Rails just, relies on a table. And they say convention of a configuration, and this is the truth in the database, and they are happy with it. And why we have to copy 20 times? And this was my argumentation, but I sometimes lost because, I was a freelancer and have to fight against a huge, not ThoughtWorks, but ThoughtWorks similar companies, I would say, right?
Yeah.
And now, because it was written in a normative way and LLMs were trained on it, we can be very token efficient, and the inference is cheap, and this is huge success. So
really, what we're agreeing on is that the enterprise Java specification is great if you're a machine, but it's caused people to have to act like machines in order to generate all of the cruft that goes with basically getting work done.
Yeah.
And what we've managed to do now is push that cruft far enough down the stack that things like Quarkus, which is brilliant.
Yeah.
And actually, bringing this full circle, this is another one of those pendulum conversations, right?
Yes.
We started at the late 90s with this big smorgasbord mess of remoting options, of durability of data store options, and then some very heavyweight organizations with a lot of vested interests came out with the most over-engineered way you could possibly do it, but it was the one true massively over-engineered way. Mm-hmm. And then the pendulum swings that way. And then Spring came out, the original Spring was how simple could we make this? And then that grew, fangs and teeth and whatever else. But, the original core Spring, what was very tiny, I was at ThoughtWorks when they were doing, when Paul Hammond and Joe Warnes and Aslak Hellesøy and whatever were doing the original Pico containers and nano containers and inversion of control. And some of the ideas that then ended up being the annotation piece of Spring. And so there was a desire to rein this thing back in, and then it swung back the other way. It became too simplistic. You're trying to find the simple essence in the middle, but it swings to either being vastly over-engineered or too simplistic to get work done. And then everyone has to reinvent, and then you get the
because of dogmatism, right? There is some the Hollywood principle and inversion of control, and everything has to be Hollywood principle, inversion of control, and then you go too far, too extreme. Mm-hmm. And I think in software engineering, if something is extremely suspicious, it is always a how to call it, a compromise, because
and it comes back. I don't think it's even a compromise, but it is a trade-off.
Yes, trade-off.
And
exactly.
that's the thing is if you understand what it is you're losing in order to gain the thing, then you can make intelligent choices. Mm-hmm. You can make informed choices. Mm-hmm. And I think a huge amount, and it's exactly the same with all the LLM hype and grift and whatever. I'm right now, I'm using Claude Code. Other LLMs are available. I'm using Claude Code very effectively to help me do a bunch of things, right? I'm not using it in nearly the way that the hype circus would have me use it. It's not running my life. I don't believe it will replace any junior developers. I'm very happy out there ranting about this.
Yeah, you are junior. You're still here, right? So
right, and we need more of them. So I think again, and unfortunately, there's $1 trillion worth of marketing budget telling you that you have to use these things. Mm-hmm. But when the dust settles, and it'll be my prediction, if we're allowed to make predictions, it was within the next year or so, there will be a huge resettling, reset of expectations, and we'll realize that these tools are useful in a bunch of situations, terrible in a bunch of other situations, a reasonable compromise in yet other situations, and as with all these things, the best products are the ones that help people work better rather than attempt to replace them. Mm-hmm. And the parts where LLMs, AI, Gen AI will help people work better, those are the products that are going to win.
Yes. And regarding Pendulum, I have to admit, similar story to Spring, because back then it was so much XML, so I ignore it. Similar story to Python. It's a Java started. Python was not very popular among Java developers. Mm-hmm. And I had no chance to use it, actually. So I understand a little bit Python, but I never wrote, I think, a line of Python code. Recently, or it happened several times. So there was some Python code, and we had to run it in production. And I said, before, with my half knowledge, I will extend it to run it. Let's migrate to Java 25. And the last thing is actually last week, and I posted on my LinkedIn the screenshots of it. And to my surprise, the Java 25 migration of the thing was, to this day, always shorter, and now it comes shorter could be. But I could just use Java 25 without external dependencies. And all the Python examples needed external dependencies. So I was surprised by that. I thought with Python will be simpler than Java. Maybe Java is more robust and types say whatever, but that the Python would be simpler to understand and shorter. It was never the case. So the last case, it was just like a launcher for inference. And the Java was, I think I remember, 30% shorter, no external dependencies. Python was longer with external dependencies. And I think, okay, what's going on? And I try, I've read lots of Java 25 scripts because you can have a share bank with Java. You can just run it. And I understand Java well, so I'm fast with it. So actually for me, it's no issue to read a file, transform a file is like one-liner. And all, whatever I migrated is shorter. So there's also an interesting part. And I even have a repository with maybe 20, 30 scripts already. So for instance, recently, what I did, I created a command line utility which searches for JavaDoc. Class, I can say string. It searches for the string in JavaDoc on my local disk, opens the browser and copies to clipboard the link. So would I save, minutes or seconds every time? And in Java, it is maybe 10 lines of code or 30 lines of code with usage notes and so forth. And it's also stunning that that is possible. I believe that Python is way simpler than Java because everything is simple and Java is bloated, and is not the case, right? So this is also interesting. And I send you maybe a link. You can look at this. And my script is even exaggerated because they are in color, and I have input validations. But if you leave it off, is like a 5 to 10 with Java streams or whatever. It is actually for a Java developer very easy to read. And last time, so I have to invite you back because actually today I wanted to talk about BDD. This was my idea, with you, because you are the BDD master, but it didn't happen. But we clarified the J2E stuff, and also as a cliffhanger, what I wanted to mention, but I didn't want it to interrupt you, that the outsourcing, the problem of outsourcing and specifying what you would like to do to an external team is very similar to working with LLMs. Because you need these specifications in the hope that LLM will generate the specification. And back then, we had the same problem because we had, to create a specification in order that the remote team will implement that.
Yeah.
And similar challenges. This is one maybe next time.
So here's the thing. That's not how I use LLMs.
No, not a problem.
My usage of LLM is much more iterative.
Yes.
Because I don't know where I'm going yet. And that's the same way I work with developers.
Yeah, this is also what I do.
And if I'm working with an outsourcing partner, it's not one shot. It's not, here's a specification. If I'm using LLMs,
this is what companies try
shot.
to do. And this is now what everyone is talking about. It's not like we should do this. It's more like, we have the same problem. Because back then I was I was hired by a TV station. And what they wanted to do is they asked me how to write a specification so that it can be implemented by external team. And what we find out is that the effort to create just a specification is maybe the same as implementing this in-house. So this was the outcome of that, right? So and having strict specification, spec driven is maybe the same, but we don't have to talk about it. But we have to talk about BDD.
I feel like that's a conversation for another day.
Perfect. Thank you a lot. Where people can find you, hire you, and
easiest place to find me, goalwoods.co is my consulting website. So it's goalwoods, as in towards a goal, .co.
Mm-hmm.
I'm on LinkedIn as Tastapod, Daniel Terhorst North. I'm very easy to find.
Mm-hmm.
Yes, I am. I'm actually wide open at the moment. So I'm very happy to talk to folks about consulting work. I run some my own training classes. If you look goalwoods.co/training, you'll find it there.
What training classes about what?
So 3-ish themes. One is general software development. So
Okay.
how do we write software better? And I guess the way I describe it is my classes aren't for beginners, right? They're for folks who've been around the block. And they're like, there must be more to it than this.
Okay.
So they tend to be mid-career, sort of senior type folks who have opinions, who want to have them challenged. I don't want to be in my classes on transmit. That's boring for me, right? I want to have Adam in my class so we can riff a bit and argue and both learn from each other. That's how my classes work.
Mm-hmm. Mm-hmm.
I then have a testing class which kind of grew out of that as a specific sort of subset, if you like. Which is it's not for testers. It's for software teams about testing. Mm-hmm. So it looks at testability. It looks at how to design for testability. What makes good automated tests. Obviously, there's a BDD segment because people expect a BDD segment, and it's a thing I like to talk about.
Next time, I will tell you why I hated BDD. So maybe this is the
nice cliffhanger. I want to hear why. Do you know what? It may well be for the same reason I hate how a lot of people do BDD.
Okay, this could be right. So this is the cliffhanger for next time.
We may be quite aligned on this, but I'm gonna write my answer in an envelope for next time, and then I'll this is what you were going to say.
Exactly. And so you have software engineering testing. This is your training.
Yeah,
right?
and then more of a kind of leadership type management. So I spend a lot of my time these days working at organization level.
Mm-hmm.
So yes, we can look at the code, we can look at how the teams are writing the code, but then how do we structure teams of teams? Like some problems are what I call wide problems. It's a
this was
60-person wide problem, an 80-person wide problem.
Business strategy. This is why this is why you know about the business strategy, right? So decisions.
Yeah, exactly. Yeah. So a lot of things that look like 80-person problems are really 10-person problems, but they've blown out of proportion. Some problems are genuinely wide, right? You genuinely want teams of teams. How, given those problems, how do you structure those folks? How do you get them so they're not tripping over each other, so you're not in loads of circular dependencies, and so people can have fun, people can work well and enjoy what they're doing and see the results of their work. So I do a lot of working with C-suite, with what I call L1, L2, kind of the folks that report into your CXOs, and then looking at programs of work. How do we structure programs? How do we structure portfolios of work? And to me, it's all the same, right? It's optimizing. It's right. How do I make the organization go faster? How do I make the code go faster? How do I help the teams work better? Is all just kind of the same thing at different scales.
Are they in person or online?
So all of my training so far is in person. I've always been too much of a coward to do online training. I'm looking at that right now, funny enough. But I find the types of training I do work better when everyone's in a room.
Yes.
And we can really kind of get into some meaty discussion.
And where is it? In London?
So I'm in London. I travel basically anywhere, Europe, non-US at the moment, but a little bit worried about flying that way. But yeah, so I've done a lot in Germany, in Scandinavia, in Northern Europe, Western Europe. I've been out I was working with a client in the Baltics.
Cool.
Earlier last year. So I'm pan Europe or UK and prepared to travel further.
Okay, Europe or UK. This is.
I'm embarrassed. I'm embarrassed that the whole thing happened. The thing is, I'm in my 50s. I've spent my whole life being European.
Yes.
Right? I identify as European before I identify as British.
Yeah.
And then 10 years ago they ripped that away from underneath me. And I'm cross, Adam. I'm cross. But yes.
Super cool. So hopefully a lot of people will sign up to your courses. And next
that'd be fantastic. Yeah, hit me up. I'm very easy to find.
Yeah. And what was the URL of your courses? Do you have a dedicated one? Testapod, you say?
So goldwoods.co is my website. The training's on there. Generally what I do is I bring it in-house. I don't do much public training. So it's in-house. It's, 20, 25, 30 people, that sort of size.
Yeah. Okay, cool.
A couple of days. And we get into some really meaty stuff.
Super cool. And see you next time with BDD, hopefully.
Fantastic.
So, this was actually what I wanted to do today.
An hour.
Yeah. So thank you a lot. And thank you.
Thanks, Adam.